Oracle Cloud APM service utilizes distributed tracing to provide LLM usage, performance, and quality monitoring. Users can use the Inferencing App Monitoring Dashboard available on GitHub to get started. The dashboard can be revised and extended to match different types of applications, like chatbots and agents. It is built to be platform agnostic, supporting the large number of frameworks available to developers. The dashboard has 3 different tabs: End User Experience, Performance and Quality, and Cost Analysis. With the User Experience page, you can see the overview of different Gen AI applications that you are monitoring. The Cost Analysis tab provides insights into the cost spent on the Gen AI applications. Here in the table view, which shows the total cost of Gen AI model usage by users, you can see the amount of tokens used and the cost associated with for each user. Token counts can be collected using APIs at the application level, or estimated based on the input and output string lengths using APM span enrichment rule. As shown here, span and enrichment rules are used to calculate the cost of each invocation, addressing the specific model prices and terms of the LLM providers, like a difference in input versus output prices. And by clicking the title link on the widget, you can see the same information in the Trace Explorer page. So here you can see the trace query statement that was used to create this table, which you can change the statement to query different information. You can create a trace query asking how much dollars I spent for the answers that were incorrect, or show me the performance of the aborted queries, for example. In the Performance and Quality tab, you can find the performance insights and validate the answers that the Gen AIs made. Left side of the screen, there is a bar chart. This is the response time breakdown by Gen AI service, which tells you how much time was spent on each service. So here I am spending most of the time in the OCI Gen AI service. The second bar is also another chat service. Third is the vector search, and fourth is the embedding. You can see the breakdown time among the services. Down here in the failed answers widget searches, the Gen AI answers that are considered as failures and characterizes by the types of answers. You can also see the actual answers and also drill down to traces to see the span details. Response Divergence widget shows drifted answers. You can gain the insights of how many times the similar questions were asked and how they strayed away from each other. You can see there were 71 questions asked for this query, and there were 58 divergences or drifts. Clicking the link, it shows the list of responses made by the Gen AI model. And the upper side of the cluster widget shows the outliers and non-outliers of the Gen AI invocations. Looking at the recent transactions, there is a group of responses with high latency. Click the bubble icon to drill down to the traces. I can see the trace duration of them are more than 20 seconds. You can further drill down to the Trace Explorer to see the trace details. Here in the waterfall view, I see the invoke span was taking longer time, while embedding the vector search spans were taking much less time. So the most time was spent on the conversation with LLM. Let's see the details of this span. I can filter the attribute list to show only Gen AI related attributes. The Gen AI model used in this span was Llama 7DB. I can see the prompt length and response length. Gen AI cost, I can hover my mouse over to see the decimal values. I can also see the question the user made in the Gen AI application in the parent span. Here is the Gen AI query which was asked by the user, and here shows the response made by the application. This is the end of the recording of the LLM Observability in the Oracle Cloud APM service. Thank you for watching.